Question number 9. As a student walks downhill at a constant speed, what will happen to his gravitational potential energy? Well, your potential energy is based on your mass times gravity times your height. So if your height goes down, your potential energy has to go down as well. So potential energy isn't going to increase, it has to decrease. But it's also talking about kinetic energy. Kinetic energy is based on 1/2 the mass times the speed squared. Well, in this particular problem, it tells us a constant speed. If your speed is constant, then that means your kinetic energy is going to have to remain the same, which means choice 4 is your answer. Question 10. When 150 joules of work is done on a system by some external force, the total energy of that system just went up by how much? Well, if you did work on a system, that means you added energy to it. And if you did 150 joules of work, that means you had to do 150 joules of energy that you just put into the system. So 1 is your choice, 150 joules. They give you the answer in the problem. Question number 11. A person on a ledge throws a ball vertically down, and it strikes the ground below with 200 joules of kinetic energy. The person then throws an identical ball vertically up at the same initial speed. What's going to be the kinetic energy when it hits the ground? Well, for this problem here, we have to understand that when you throw a ball straight up into the air, when it comes back down to your hand, whatever speed that ball was initially, let's say it was 10 meters per second, that's going to be the speed it reaches when it matches where it left your hand. So it'll leave your hand at 10 meters per second, and when you catch it, it'll still be 10 meters per second. Why does this matter? Because in the first part of the problem, it said that the person threw the ball straight down with some speed. And this speed is the same speed that the person threw the ball straight up at. Well, in this case, if the person threw it down at 10 and then threw the ball up at 10, regardless that the person threw it up, it still is going to be leaving the hand at 10 going back down, which means the kinetic energy at the bottom is going to be the exact same of 200 joules because this speed leaving the hand is the same. Question 12. 2 construction cranes are used to lift 1,200 kilogram loads, the same vertical distance. The first crane lifts the bricks in 20 seconds. The second crane lifts the bricks in 40 seconds. Compared to the power by the first, what happens to the power by the second crane? Well, let's compare the two. Crane number 1, crane number 2. In this case, we're talking about power. So power is work divided by time, which in this case is force times distance divided by time, which again can be broken down even to more because the crane is lifting. So this force of lifting weights, mass times gravity times distance divided by time. So this is the equation that I'm analyzing here. The power for crane number 1 and crane number 2 is dependent on the mass times the gravity, that's the weight that the crane lifted, times the distance it lifted it divided by the time. So my power is going to be 1,200 kilograms. I'm going to use gravity as 10 for a multiple choice problem to keep the numbers simple. The distance, it says, is the same, so I'm just going to put 1 meter in. Why? Because 1 is the easiest number to use, and time in the first crane was 20 seconds. I do the same setup for crane number 2. But now my time is 40 seconds. And when we punch out the numbers, we'll end up that the first crane does 600 watts of power. Meanwhile, the second crane does 300 watts of power. So the power developed by the second crane is half as great. Number 13. An ionized calcium atom has a charge of plus 2 elementary charges. If this ion is accelerated through a potential difference of 2 times 10 to the 3 volts, what's the kinetic energy gonna be? So I need an equation with elementary charge, energy, and potential difference, which is the fancy way to say voltage. Let's hop to the reference table. Well, voltage deals with potential difference and electricity. So I'm in the section of electricity here on my reference table. And if I scroll down here, I'll end up with a V is equal to a W divided by a Q. And if we analyze these pieces, it tells us that V is the potential difference, W is my electrical energy, which could be potential or kinetic, and Q is my charge. So I have to use V is equal to W divided by Q. I plug in my pieces. Q comes from my elementary charge. Elementary charge, once again, we find in the reference table. One elementary charge is 1.6 times 10 to the negative 19 coulombs. But I have two of them, so I'm going to throw a 2 out front. From here, we can calculate that our W ends up being 6.4 times 10 to the negative 16 joules. The problem is they don't tell us joules, they tell us here electron volts. So we have to do a conversion. We stick a little 1 under our answer, and we go to our reference table to find what 1 electron volt is equal to. It just so happens 1 electron volt is 1.6 times 10 to the negative 19 joules. So we divide, and we end up with a final answer of 4 times 10 to the 3 electron volts. Question number 14. A total charge of 100 coulombs flows past a fixed point every 500 seconds. What is the current for this particular circuit? I'm looking for a current, so I head on over to the reference table and look under electricity for current. I don't remember what current is, but I know the word current, and it tells me it's I. So an equation has an I. Here's one with an I. It just so happens it also told me the charge and time, so I equals Q over T. 100 coulombs for every 500 seconds. And this gives you 0.2 amps. Question 15. An aluminum wire has a length of 1 meter. Has a resistance of 9 times 10 to the negative 3 ohms. If the wire were cut into 2 equal lengths, each length would have a resistance of what? Well, the resistance of a wire is equal to rho L over A. So rho is constant because it's aluminum wire. L is changing and A is constant. It doesn't tell me I'm changing the cross-sectional area. What happened to the length? Well, the length was cut in half. Well, then what would happen to your resistance? It's got to get cut in half. So instead of 9 times 10 to the negative 3, 4.5 times 10 to the negative 3. Question number 6. In an electrical circuit, the source of potential difference. Potential difference is just a fancy way to say voltage. Well, voltage is given to you by a battery. A light bulb has a resistance of 2.9 ohms. It's operated with a 1.5 volt battery. At what rate is the electrical energy being transformed? And that is my power. So taking a look here at my power formulas, I have to utilize one of these particular choices. And in my situation, I know what the voltage is and I know what the resistance is. So I'm going to use V squared over R to solve for my power. Power, how fast am I using the energy? In this case, it's electrical energy. So that is going to be 1.5 volts. Don't forget to square it. And my resistance is 2.9 You'll end up with a power of 0.78. What? Yes, that's what I said, 0.78. Question number 18. A 40 kilogram child exerts a 100 Newton force on a 50 kilogram object. The magnitude of the force that the object exerts on the child. Well, if a kid is pushing some box with a force of 100 newtons, then that means the box is going to push back with a force of 100 newtons. This is Newton's third law of motion. For every action, there is an equal but opposite reaction. So 100 newtons is my choice. Are you excited to learn more of the 2019 Physics Regents exam? If so, then click the link below to page 4. Or perhaps you missed page 2. If that's the case, click the link to the left. It's simple and true. Let's get it.